This is Kings Creek on Konza Prairie Biological Station. We're at the downstream permanent flowing part, and it's forested riparian zone. As we work up into the higher reaches, it's covered with more grasses and less trees. This is an oak-dominated forest that we're in, and it shades the stream channel, but you get pretty good algae going here. We can have really large floods here. Big thunderstorms come through and make massive floods that would flow over actually the bank that we're sitting on. But every year, for the most part, it dries out during this time of year or a little bit later, and thus it's an intermittent or ephemeral stream, depending upon which reaches you're in. Upstream, there are some more permanent spring-fed reaches that serve as refugia for the aquatic organisms. Now we're in a grassier banked area further upstream, and this is K2, and it's no bison, but burned every 2 years. This is a spring-fed area that serves as refuge for the fishes, and they can outlast most of the droughts, except for the most extreme droughts up here. If the drought completely dries this, then they've got to come up from down below where we were, but we're about 5 kilometers up from where we were there. This is one of our weirs on Konza, and they've been running since the 1980s, and they're used to measure discharge. The stream right now is dry, but you can see a little pipe down there, and that pipe goes straight back into this unit right here, which has a bubbler in it and a vertical pipe that goes down. So the higher the water is, the more pressure it takes to push those bubbles out. It's got a data logger in there, and then it's got solar power to run all that. And then we have a wireless transceiver that sends a signal off to Konza headquarters and then back to Kansas State University. In addition to that, this is a site where we did a woody removal experiment to test the effects on the chemistry and hydrology of this small stream. If we look around on this direction, you can see how dense the woody vegetation was around this stream. In 2010, we removed the woody vegetation. There's a little bit of a tree left there. And every year we came back and knocked it back again. We saw big spikes in nitrate for the first few years, but then it dropped back down to the ambient levels. We also have seen a change from the benthic primary producers. We've gone from mosses in the shady part to algae in the stream in the sunny part. In addition to that, there's very few leaves in the streams, so the invertebrates that eat leaves are not doing as well when we've taken the trees out. You can also tell we're in the bison area. If you see, there's a herd of bison there. So they're also having some influence on the system. They slightly increase the nitrogen in the system, although not nearly as much of an influence on the water quality as the cattle. And we've done comparative experiments on those too. One of the big findings from Konza in the water quality is that the nitrogen transport is very low from these streams, suggesting that tallgrass prairie in general, even though we have some nitrogen-fixing species in it, is a low producer of nitrogen, and that the high nitrogen streams we see in former areas of tallgrass prairie that are now in cropland are not natural. They're artificially increased by the fertilizer that's been added to those streams. This is Edler Spring. And there's a spring that comes out of the hillside, and it's put into a box here. And the box, it goes into the water system below. It was originally for cattle, but we use it for research now. Maybe you can see little white dots on there. Those are isopods. They're blind and unpigmented, and they are subterranean their entire life cycle. We've studied those, and there's also blind, unpigmented amphipods, and very occasionally there's some larger planaria that are also blind and unpigmented, and they're several centimeters long. This is the USGS, United States Geological Survey, gauge on Konza Prairie Biological Station. Here's where they beam the data from, and the sensor is a bubbling pressure sensor to measure discharge down there. You can see in this intermittent stream it's not flowing now. This site has been running since the late 1970s. It's the only hydrologic benchmark network site, HBN, in grassland. So the whole watershed above here is in grassland, and you can see the dry channel above. HBN, hydrologic benchmark network sites, are mostly pristine sites or reference sites, and they're used to tell what's going on hydrologically in areas without the anthropogenic input, and they can then be compared to the sites that do have anthropogenic influences. This is the aquatic neon site, and here we have the weather station for the site, and then here's where all the power comes in, and also they send the signal out via wireless from the sensors. NEON is the National Ecological Observatory Network, and this is the site in the Prairie Peninsula at Konza Prairie Biological Station, and this is Kings Creek. The plan is to sample water chemistry and quality for 30 years and the physical parameters associated with it. We're looking at now is a set of the NEON sensors. Then these are all streaming to online. You can see they're connected with a cable, and the cable comes up past Gretchen, and then all the different sensors are going into that. It's relayed then, the data are relayed from here out